Welcome to the final project demonstration of the Globex network delivery. This video will demonstrate NIC Teaming, Cisco routing and switching, security, terminal services, Microsoft Exchange, and server backups. To help us understand the contents of the following videos, we will quickly refresh our memory of the network designs. Here we can see the Wagga Wagga network connections, followed by the Albury network connections. To demonstrate NIC Teaming, we will look at the Wagga host server. Here we can see our active and standby interfaces. We are running a constant ping to the internet. If I disconnect the active interface, we will see traffic being forced across to the standby interface, which now becomes active, and in the process we lose one packet amongst the pings. I am now logged into the Wagga router 1, where I will run some basic show commands to demonstrate the network topology. Here we can see our 3 VLANs on the router, which refer to the corporate, guest and management networks. Here we can see on our dialer 1 interface we have our dynamically assigned public IP address from our ISP. If I do a show CDP neighbors command, we can see here that Wagga switch 2 and Wagga switch 1 are directly connected on this router. I will now log into Wagga switch 1 and display the Ether channel connection between switch 1 and switch 2. Our port channel 1 interface refers to our Ether channel. If I do a show Ether channel summary, we can see that the interfaces involved are Fast Ethernet 0/22 and 0/23. If I do a show CDP neighbors command, we can confirm that these interfaces are in fact directly connected to Wagga switch 2. Now moving back to the Wagga router 1, I will demonstrate the spanning tree topology of the layer 2 portion of the network. Here we can see on all 3 VLANs we have one interface blocking and one interface forwarding. This is because Wagga switch 1 is the root bridge for the layer 2 network. The router has one interface which is blocking. If we do a show spanning tree VLAN 51 brief, we can see that this interface, Fast Ethernet 010, is blocking, which is as per the design. I will now demonstrate some basic security parameters on the router. Here we can see our access lists which are configured. We have configured in a way that only the corporate and the guest networks can access the internet via NAT. The management network should not be allowed. We can prove this now by running ping commands sourcing from VLANs 51 and 61, which are successful. A ping from VLAN 71 is unsuccessful. I'll now demonstrate that NAT is functioning correctly. We can do this by running the command show IP NAT translations and filtering by the IP address that we just pinged, that being of 8.8.8.8. We can see here our 2 entries are correct for the 51 and 61 subnets. Another security feature implemented is that the guest network should not be allowed to access the management network. We can prove this now by running a ping command to the management VLAN IP address. We can access this from VLAN 51, which is a corporate network, but when we try and access from VLAN 61, which is the guest network, it fails. I will now demonstrate terminal services where I will connect to the Globex network from a remote client in the field. To do this, we are using OpenVPN software, where the server end of the connection is on the Wagga host server. We can see here we are now connected and we have been allocated an IP address of 192.168.41.6, which is the correct subnet which has been allocated for remote user traffic. We can see here we've got some pings running to the cloud server and also to Wagga router 1, which proves that routing is enabled through this VPN. Moving over to the web browser now, we can demonstrate our remote desktop services web link, which is located on the Wagga domain controller, and we can also show the intranet website, which is located on the cloud server. Connecting to both of these sites proves that DNS is functioning through our OpenVPN connection. Here we can see the intranet site, which is still lacking content, but the platform is ready and available. Our remote desktop services web link, we can see our published programs for the client and also a remote desktop connection function, which allows connectivity to other connected devices on the Globex network for remote access. We can also see that the remote client has access to their share folders via the VPN, which they would normally have access to when they were directly connected on the Globex network.
Here we've got the Albury Exchange server. You can see its Ethernet address from the Albury domain. These are the mailbox for the users at both the Albury and Wagga sites. You can see they've got the globexfarms.com domain email address. If we look at a user here, some of the mailbox settings, you can see he hasn't logged in yet. You can also see the mailbox size settings there. If we have a look on the domain controller, look at the DNS settings, you can see the globexfarms.com forward lookup zone with a mail host resolving to the correct IP. This is a mail.globexfarms.com certificate that we're using. This is the DNS settings at GoDaddy where the domain's registered. So they're both pointing to the public IP. And we've got a mail exchanger record there pointing to the correct mail server. Okay, now we'll try sending an email from, you can see the Albury account computer here for Mark Baker. This is his Outlook application. Send one to an external email address and one to Max Brody, an internal user of the Globex company. Just send this test email off now. Just using the Outlook web app for Max Brody. We can see that message is coming from Mark Baker there. We reply. Go back to Mark Baker's Outlook. We can see that message has been returned successfully. Now we'll check the public one. We can see it's come through there from Mark Baker. Reply to that email address. We'll go back to Mark Baker's Outlook. Hopefully we'll see it there. And we do. There it is.
This is a test and demo video for the backup solution for Globex. This will be shown on this Windows server here, which will be the Windows portion of the backup solution. I'll also show the Linux side, which is the NFS server portion of the backup solution. Just quickly, we can see here in this folder that there's no files. This is where the NFS export is pointed to. We can see that export by just doing a cat of the exports file. And we can see that we've got two exports, one for Wagga and one for Albury. These are locked down to allow all of the Wagga local subnet to connect and only one of the Albury servers to connect. Over on the Windows side, we use the built-in Windows backup tool to do the initial backup of shares, and this is backed up just locally onto the C drive in Windows Image Backup folder. And there's a folder with the server name, in this case, saved to the local drive. Once the Windows image backup is complete, and which happens once a night, there is a script in C scripts, and this is a simple batch file that just mounts the NFS share, does a timeout just to make sure that it's all mounted and ready to go, then performs a simple X copy of the Windows image backup contents to the X drive that we've mounted, and then it unmounts the drive. To run that script, we use a scheduled task that also runs once a night, and this runs, as you can see, at 10:05 p.m. every day. To demonstrate this all in action, aside from this 10:05 p.m. trigger, I'll run this task. So what this will do now is run the script that I've just shown you here. It will copy the files from Windows Image Backup over here into the NFS share on the Linux side here. So by now we should see the WAG DC01 folder is populated. There we go. That will take a little while to copy over the link that we have, but you can see within that folder there that there's some other files. There we go. So we have a backup for the 25th, which is today. Thank you.